All right, this is Chapter 5, Section 1. Our learning objective is to classify polynomials, and we can do that in two different ways. And then to graph polynomial functions and describe their end behavior. A monomial is a real number, a variable, or a product of a real variable or a real number and one or more variables with whole number exponents. That's a monomial. Mon being the root meaning 1. So if you got one little guy out there, you know it's going to be a monomial. Degree of a monomial is the exponent of the variable. So whatever is on the x or whatever letter they're deciding to use is the degree. A polynomial, our root word being poly, meaning many or multiple. A polynomial is a monomial or sum of monomials. So a monomial can be a polynomial. So a polynomial is a monomial or a sum of monomials. The degree of a polynomial is the greatest degree amongst your monomials. So in one variable, it's the greatest degree. I don't think we're going to talk about degree with more than one variable, but if you run into that, let me know, because that's an easy one to press with as well. All right, so all these wonderful terms for standard form of a polynomial, you'd arrange your terms by degree in descending numerical order. So if you have a 5th degree is your highest, you go from the 5th degree to the one below that degree to the one below that degree, etc., etc. So a polynomial function, you'll see it like this. P of x is equal to a sub n, x to the n, plus a sub n minus 1, x to the n minus 1. So look what happens here. If this is a 5th degree, this would be 5 minus 1, or 4th degree. The next one would be 5 minus 2, which would be 3rd degree. So all this is counting down from your highest degree to your constant term. Your constant term has no variable on it. Where n is non-negative, integer, and a sub n to a sub 0 are real numbers. Here I do want you to write down the different terms. When you have a 3rd power, it's a cubic. When you have a 2nd power, it's called a quadratic. When you have just a power of 1 or just the x, it is a linear term. And then when you don't have any letters on it, it's a constant term. Okay. So you can classify a polynomial in two different ways. By using its degree, and we've already written some of these down already, so or you can classify it by how many terms it has. So if I have a 0 degree, so think about this. What is x to the 0? X to the 0 is 1, and then 1 times a number is just the number. So if I have a degree 0, that's called a constant. It can have 1 term, and that's called a monomial. If I have a degree of 1, so x to the 1 or just x, we know what that's called. We've dealt with that before. It's a linear. Using the degree, it would be a linear classification, polynomial. We can have x plus 4. In this case, when we have x plus 4, that's 2 terms, binomial. Degree of 2 is a quadratic. Here they have 4x squared. This is just 1 term, so that's back to monomial land. Degree of 3 is a cubic. For example, 4x to the 3rd minus 2x squared plus x. These are 3 terms. 3 terms, thank goodness, is a trinomial. Try theme 3. Degree of 4 is quartic, so like 2x to the 4th plus 5x squared. There are 2 terms in that expression, and that's the binomial when it has 2. Degree 5 is quintic. So, for example, a negative x to the 5th plus 4x squared plus 2x plus 1. There's 1, 2, 3, 4 terms here. And anything after try, we just say it's a polynomial of 4 terms. If it has 7, it'd be a polynomial of 7 terms. So we stop giving it the fun root word names after trinomial. All right, so for A and B, we have to write each polynomial in standard form and then classify one by degree, or classify both of them by degree and by number of terms. So standard form is has the highest degree first. 5x to the 4th is definitely has the higher degree, so he gets to go first. Plus 3x to the 3rd minus x. And then this is degree 4 because it's the highest exponent. And terms, it is a trinomial. Because there are 3. Okay, so for this one, we would go 4x to the 5th is the highest degree. He has a negative on the front, so don't forget to include him. Because if you guys typed this in when you're doing your formative assessment and you forget the negative, it will be marked wrong. The next highest is this 2x squared. And technically, I can combine 3 and 10. 3 plus 10 is 13. So if I were to classify this by degrees, it would be a 5th degree. And by terms, it would be a trinomial. All right, that's as difficult as that, and that is our first learning objective. So let's look at our second learning objective. It's talking about graphing polynomials and determining what happens for the end behavior. We're going to be talking about turning points. So those are places where the graph changes direction. So if I was going, and you always look at them from left to right. So if I go from left to right for this graph, I am decreasing, 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 and then I change direction here, and now I'm increasing, increasing, increasing. And then I change direction here, and I'm decreasing. And I change direction here, and I'm increasing, increasing, increasing. So the turning points they're kind of like the peaks and the valleys of your graph. The end behavior, or the directions of the graph, are the directions of a graph to the far left and to the far right. We're going to concede that there may be some wiggling going on in the middle, but as you go out to negative infinity and as you go out to positive infinity, the graph gets pretty consistent. It's either going up all the way, going down all the way, or reaching an asymptote behavior. Okay, so make sure you sketch this graph on your paper. We are the end behavior. So as we get really negative or approach negative infinity, our graph is going up. So as we go closer to negative infinity, we're going to get more and more higher. We're going up. And then you look at it as you go towards infinity. What's your graph doing? Oh yeah, he's going up as well. So we say our end behavior is up and up. Up on the left, up on the right. So your turning points are I like to think of them as the peaks and the valleys. So it's where it's right where you change direction. So there's one right here. There's one right here. There's one right here. So our graph has 3 turning points. And then let's do increasing and decreasing. Let's do decreasing is going to be our purple crayon. So we are decreasing from here to here. This little snippet right here. And that's the only 2 places we are decreasing. We are, and then we are increasing on these intervals here. So let me increases and here. All right, so we're going to look at y equals negative x squared plus 2x. We know because our value in front of our x squared is negative, it's going to be a frowny face. When we have frowny face behavior, our end behavior is going to be down and down. Our turning point is right there at our vertex, and we are increasing from negative infinity to our turning point, and from that point to an infinity, we are decreasing. Okay, so if we look at our cubic function, y equals x to the third, we call that our little, he's a swimmer, he's a little diving into the water. When we have a cubic function, we have the end behavior of down and then up, because it's down on the left and up on the right. There are no turning points because we are always increasing. So we are always increasing. So it is possible to have no turning points. And it's okay.
Do the same.
All right, so here we have a cubic that has a negative in front of the x to the third. We are reflected across the y-axis. It's plus 2x, so we get a little bit more wiggle in the middle than our parent cubic function. Our behavior is up and then down. Because we're up on the left and down on the right. Our turning points are right here. We have 2 of them. I'm going to call it TP, not toilet paper, but turning points. From left to right, we are decreasing until our first turning point. Then we go ahead and turn. We are increasing till our second turning point, and then we go back to decreasing. So blue is decreasing, the black is increasing, the blue is decreasing. So the end behavior of a polynomial function with a leading term a times x to the n. If n is an even number, so you have x squared, x to the 4th, x to the 16th, anything even, then your end behavior is going to be up and up. So it's going to be up on the left and up on the right. Touchdown. Up and up. if your a term is positive and you have an odd function, then you're going to be down. You're going to start down, and then you're going to go up. And then a negative will reverse all that. So if you have a negative coefficient, instead of being up and up touchdown, you're going to be down and down. Think about a negative x squared is a parabola that's round in face. It's got down and down. And then the odd, when you have a negative coefficient, the odd switches instead of being down upwards. So in general, the graph of a polynomial function of any degree has at most n minus 1 turning points. So if I have an x to the 5th power, and you tell me there are 6 turning points, I'm going to say, lie! Because I know that the graph of a polynomial function of degree n has at most n minus 1 turning points. All right, so we are not going to graph this, but we are going to determine the end behavior of this polynomial function, negative 4x cubed plus 2x squared plus 7. So if we just look at negative 4x to the 3rd, he is odd, and he's got a negative coefficient. So that would be up, down, up. So your end behavior is up and down. All right, for A and B, we are going to have to find the graph of each function and describe the graph. Yay! So not only are we going to do the behaviors, we're going to identify turning points, and yeah, it's going to be mega fun. All right, so we're going to throw this in our graphing utility. We already know that the end behavior is up and down, but now I want to use the graphing utility to find the turning points. Negative x cubed plus 2x squared minus x minus 2. All right, so we're going to zoom in on the essentials. So as you can see, we are decreasing until .33, comma, negative 2.148. So we have a turning point. So let's identify. So write that. Make sure we write that down. We got a TP at 0.33, comma, negative 2.15. Let's also remark that we are up, down. And we are decreasing when x is less than 0.333. Oh, hold on. Let's check this out. We have a little bit of an increase here at 1. So we got another turning point at 1, comma, negative 2. That's awesome. Nice little TP. And so we are decreasing when x is less than 0.33. We are increasing between 0.33 and 1. And then we are decreasing again when x is greater than 1. So we are up and down. We have 2 turning points at 0.33 and negative 2.15, and 1, comma, negative 2. We decrease from negative infinity to 1/3, which is the same as 0.33. And we increase from 1/3 to 1. And we decrease again from 1 to infinity. All right, so let's do this graph. I don't really even need to graph it, but I'm going to so that I don't have to draw it by hand because I'm not so good at drawing graphs by hand, freeform. So we have a odd function, but the a value, our coefficient in front of it, is positive. So we are a down-up situation. Down-up. So our end behavior is down, up. We have no turning points. No turning points because we are increasing forever and ever. From negative infinity to positive infinity. We're just keeping on getting bigger. It's awesome. It is shifted down 1. So instead of going through the origin, it goes through 0, -1. And that's all we can say about that function. So we are going to take a graph, or a table. So we're going to take a table. And we're not even going to graph it. You know how if we were looking for, like, which is the function of best fit, we have to put this pin in its table and then plot the points and then see if it's quadratic or linear. We're not going to do that. We're just going to determine those things by looking at the table. So if the first differences are constant, so we're going to find the difference between each of our y terms, and if it's constant the first time you do it, it's linear. If they don't get constant until the second time you do it, it's quadratic. If it doesn't get constant until the third time you do it, then it's cubic, and so on. So let me show you how that works here. So the difference between 23 and -16 is 39. The difference between -16 and 15. So it is second minus first. So it's the next one minus the first one. So you go -16 minus 23. And the difference between the first and the second is -39. Then this one would be -15 minus -16. And the difference between the next two is 1. Then between 15 and 10, so you just go the one before. -15 minus -16, -10 minus -15. So we're just finding the difference between each one of these. -10 minus -15 is -10 plus 15, which is 5. Then we do between -13 and -10. -13 minus -10 is -13 plus 10, which is -3. And then it's -12 minus -13, which is 1. And then we get 29 minus -12, which is 41. So do I have a constant change between my y terms? No, but this is our first difference. So we're going to do a second difference. And if my second difference works out, then I'm going to be a quadratic. If my third difference works out, then I'm a cubic. So the difference between, so you go 1 minus negative 39 is 40. So between these two. And I got 5 minus 1, which is 4. Thank you. Then I have negative 3 minus 5, which is negative 8. Then I have 1 minus negative 3, which is 4. And then I have 41 minus 1, 40. So my second difference is not constant. So we're going to go third differences. So we're going to go 4 minus 40, negative 36. Then we're going to go negative 8 minus 4, it's negative 12. Then we're going to go 4 minus negative 8, which is 12. And then we're going to go 40 minus 4, which is 36. Not constant yet, right? Not yet. So that now we're going to do fourth differences. Super fun. Okay. So my fourth difference is going to be negative 12 minus negative 36. So tiny, I'm running out of room. Which is 24, thank you. 24. And then I got 12 minus negative 12. 24. I'm so running out of room. And then I have 36 minus 12. 24. So it is fourth difference is when I get the constant. So it is, thank you, Nolan, quartic. Quartic. And that's the end of